This is the sixth video in the sequence on the Polarfire Icicle Libero Smart Console bring up. And in the last video, we actually got the blinkies, the LEDs to be blinking at about 1 second, which is what we expected. So that's working great. And now in this video, we're going to get the MSS RISC processors to talk to the FPGA Fabric Gateware to control the blink rate. And so here we go. First thing before we switch over from Libero to Soft Console is we need to find out what address, what memory map address the blinky is at. And we saw a clue to that in yesterday's or 2 days ago video where in the peripherals block there was an address decoder. So let me just hold down, scroll in. All right, this is the peripherals block that had the clue. So let's left double click to go into it. And here is if we press the control button and scroll in. Is that somewhere? So here's our blinky. Oh, nice and proud. Are we proud? And here is the APB bus. And if we right click on it, we can go to the driver. And now, right here, look at that. So that's coming out and it's saying it's on the Fabric Interconnect at Fabric Interconnect 3. And it's at address 4 and a bunch of zeros, and those last two nibbles are programmable. And if we go into our blinky goes here. We have the address coming in here. The address is here. And right here, we're looking at the lower byte, the lower two nibbles, 7 down to 0. And when it's 7 down to 0 is 4. So the lower byte, or the lower two nibbles, is a 4. That's when we load the blink rate. So let's go back to that and say, so that would be, these two would be 0, 4. So what we're looking for, what the address we want is for 0, 0, 0, 0, 0, 0, 4. And that's the address we need to write to from our C code. All right, so now we can shut down Libero and start working on the soft console again. So that's gone. It's gone. Oh, also, I cheated as well. So here's a document here on Microsemi's document. It's a very useful document called the MSS Technical Reference Manual. I put the link in the description. And in this, it gives a memory map address and the memory map space and the FIC3, the FIC3, the Fabric Interconnect Controller 3. It's located in the address range of 4 and a bunch of zeros up to just short of 6 and a bunch of zeros. And so that does fit in with ours, in which we're starting right at the beginning of the space, and we're at 4000004. All right, so now let's see if we can go in and bring up so right. Here's our workspace, which we set up in a previous video. I think that's the first in this series. And let's click on the launch. So here's the project. And I think you can click on this little arrow, kind of opens up the project a little bit more, the file, the directory structure. I think you can click on this one here on the sources, and that opens up. And if you click on this little angle bracket, these are all left clicks to open it up. That's a left click. And here are essentially all the 5 RISC processors, these hard 0 through 4. So let's go to this arrow and left click on it. And there is our E51 code, which is where we're going to put our change. So just double click on that, E51.c for this pane, and that opens up the editor. And now what we want to do is go to where it begins. And the E51 code begins with void E51. So instead of void int main, it starts out at E51. So that's equivalent of what is main in a typical C program. All right, and so they got a few initialization things. They got some sort of MSS configure clock reset function. And here they start going in and initializing the UART, which is what the first video was all about, was the UART. So let's put in some code right before we initialize the UART. And very importantly, after the MSS config clock reset block function. This function, if it's not called, will hold the FPGA is in reset and this takes the FPGA out, the gateware out of reset. So we need to take the FPGA out of reset with this command before we can do our write to change the blink rate. So right now we're going to say, write in a comment, change the blink rate. So I'm seeing here they've got the keyword volatile used. I kind of like that keyword. And also I like to see that they have uint32 used. So that's in their code. So let's control C that and control V that here. And now let's create a pointer to, I don't know, let's call it blink rate pointer. And let's initialize it to, this is also, it's going to be a pointer to uint32t pointer. So that's what it is. And we'll go to here, and what was the address we said earlier? It was OX4123 zeros, 123 more zeros. So it's like what, 6 zeros and a 4 semicolon. That looks good. Need a return. All right, now let's create another variable because I think we'll eventually get to do this of u int 32t and call it blink rate local. So this is the rate that we have inside of our code. Inside that's like just a standard regular variable inside of the RISC processor. And let's initialize him to what we want our new blink rate to be. And so our clock rate for the FPGA is, I believe, 100 megahertz. So that means that there are 100 megahertz. There's 100 million clocks per second. So if you put in 1, 2, so 100, 1, 2, 3, 1,000, 1, 2, 3 million. So there are 100 million clocks per second. So that is the default blink rate. that that we made the blinky power up at. And we can even look at that code one more time. Can we? Can we? Can we? Can we? Can we? Can we? No, because we did leave Libero open, so we didn't close it. So let's look at Blinky. And so that's the same value here. Let's see, we actually got it right. Control C. Let's get him out of the way. Minimize. And let's spaces. Start. Look at that. Those are the same two values. Now what we're going to do is we want to make this guy blink a lot faster. How about like say 10 times faster? So there. All right. So now we've got value in there that's a blink rate that's 10 times faster than the power up reset blink rate, which I'm looking at right now. All right. And now we want to write that value into contents of blink rate pointer that's assigned to blink rate local. Huh, look at that. And that is the new code that we're going to put in. And so this is how we should be able to write a local variable into the FPGA fabric. And the important thing is that the address range for the FPGA APB3 FIC3 is from OX4 and a bunch of zeros up to OX6 and a bunch of zeros -1. All right, so let's see what happens when we do a Control S. That saves the code. Now we're going to go to the hammer to build limb debug. And we're going to left click on the hammer. He's running. My FPGA is still blinking at 1 second. Great, which makes sense. Perfectly good sense. All right, because the code hasn't done anything. And so now we've just successfully compiled the code. So now what we're going to do is go up to the Run button, this green button right here. And we're going to click on it. And when we click on the button with a left click, that should run our code up to the start of the E51. And then we're in debug mode, so it'll suspend there and wait for us to resume. So our blinky's still going at the slow rate, and we're going to click here. Right. We are now suspended, and our blinkies have stopped. And that's because it's being held in reset by the processor block. And we need to run this command here in order to take the FPGA gateware out of reset. So it's being held here. And now we're going to press resume right here. Left click. I think it's running. But my blinkies are no longer blinking. Oh my goodness, they just started blinking. They're blinking very fast. This code is working. And so that is how you can have your C code running on the MSS RISC processors control your FPGA fabric over the APB bus. I think that's all we need for this video. Let's shut it down.